Okay, the energy is transported to the surface of the sun from the inside. So energy is transported from the inside to the outside by the radiation, by propagation of the photons. Energy is transported from the inside to the outside by the photons, by light. Photon produced at the center of the sun. Photon is produced at the center. Can freely move if there is no electrons inside of the sun, but it's not true, with the speed of light. Speed of light. Then, how long does it take? Just only to get out from the surface of the sun, it takes only 2 seconds if there is no electrons. But as you know, we have sun has a number of the electrons here. This number of electrons is prevent the free motion of the photons inside of the suns. So photon is produced. Always photon is actually collide with a number of the electrons. Can move, is collide. A number of the collisions happened. And finally it get out. And this question, how long does it take for the photon to escape from the inside of the suns? Then it's quite difficult questions to answer these questions. But we can use some models. We call the random walk model. So in this case, we could consider toss a coin. When you have a head, move in the positive directions. So horizontal direction is a number of how many times you toss the coins. And then 0. So you started from here, and this is distance from the centers. In the first try, if you have a head, you can move the direction of the positive directions. So this is the positive direction. The first times, this is L. And the second times, you might have tails. Then you move to the opposite directions. So this is if you have a tails. Second tries, you might have a. Then third tries, you might have a tails. Then move to the next negative direction. And then one more times, you might have a tails again. Third tries. Then minus 2L. Third try. And the fourth try, you might have a head. Fourth try, you might have a head. Then move to the positive direction. Then, actually, each step, actually the position is moving the positive or negative direction. We call this model is a random walk models. We can use this model to describe the motion of the photons inside of the suns. Sometimes photons move the positive direction and negative directions. Okay, it is random motions. Then we'd like to use some mathematics. In the very first times, d sub 1 the positions is equal to the L. And the length of the motions is capital L. So even if you make a squares, it's quite same. And the nth times, nth time is depend on the n minus 1 times. So d sub n is equal sometimes d sub n minus 1 plus l. So in these cases you have a head, or if you have a tails, d sub n equal d sub n minus 1 minus l. So depending on the head or tails, you might have two choices. So in this case, you can take squares in the both equation, d sub n squares. From these equations, you could have a d sub n minus 1 squares plus 2l d sub n minus 1 plus l squares. Or from these cases, d sub n squares, d sub n minus 1 squares minus 2l d sub n minus 1 plus l squares. So using these two expressions, you can find the average of these two equations. So d sub n squares average is equal to d sub n minus 1 square plus l squares. So this part is cancelled out. So we have already known d sub 1 square is l squares. So using these equations, d sub 2 squares is d sub 1 square plus l squares. So this means 2l squares. So you can easily find the d sub 3 squares, d sub 2 square plus l squares. So this means 3l squares. In general, d sub n squares is obtained n times l square. So the distance, you can calculate the positions of the photons after the n times. Take a square root. D sub n squares. It becomes square root n times l. This is the position of the photons after the n trials. Okay. Then we can use this equation to find the position of the photons. So after the n collisions with electrons, the photon is moving. So that the photon is started at the centers, is moving back and forth. After the n collisions, you can find that this position is a square root nl. So if the distance is larger than the r is a radius of the sun, square root nl, then a photon escapes from the sun. Then we can calculate the required number of collisions for a photon to get out of the interior of the suns. So r is a radius of the suns equals square root n times l. From these equations, required number of collisions can be calculated. And n equals r squares over l squared. This is the required number of collisions for a photon to get out of the interior of the suns. So total distance for a photon to travel is given by nl. The total length of the photon to travel is n times l. By dividing the total distance by the speed of light, we could find the times. So this is times. This is the total distance for a photon to travel. Distance divided by speed of light, you can find the required time for a photon to escape. Then you can substitute this n is here. Then it becomes r squared over cl. And then you can substitute the radius of the suns. And this is 0.5 centimeters. Then you could calculate how long does it take for a photon to escape from the surface of the suns. A photon originally produced at the centers of the suns and moving, and colliding with the electrons. And actually it takes 10,000 years. So you might be so surprised. We know the sun light is coming from the surface of the sun, and you can see that this light on the earth. So it takes 8 minutes. So maybe you have learned these ones. But these photons originally formed about 10,000 years ago. And it takes 10,000 years actually get out from the interior of the suns. And finally it can escape from the surface of the suns and come to our eyes. It takes 8 minutes. But this photon was produced 10,000 years ago. So this is the end of this practice.